Okay, hi everybody. So welcome to the British Geological Survey's latest webinar. We're launching today our new updates to the GeoScour data product. In this webinar, we'll provide you with an overview of the datasets and some of the key updates. And we also note as well how river erosion might impact on a range of assets, both within the river channel itself and assets that might lie adjacent to it, such as infrastructure and buildings. So I'm Katie Lee, team lead for geohazard product development at BGS, and I'll be hosting this 30-minute session where you'll hear from some of the scientists and developers who have been involved in GeoScour. So in terms of the running order, I'll shortly hand over to Majdi, who's a hydrogeologist and groundwater modeller. The baton will then pass on to Clive, GIS analyst, and then to Rob, geologist and geospatial expert. And they'll all walk you through the product in a bit more detail. And then at the end, we'll open up for a Q&A session. So just before we start, to make you aware that we are recording this session and we'll make it available afterwards. So we're all probably very familiar with Zoom by now, but just to remind you, if you can use the Q&A function, if you have any questions you'd like to submit, that's easier than using the chat, just so we can keep track that way. And if necessary, we can arrange for follow-up conversations as well. So now I'll hand you over to Majdi, and I hope you enjoy the webinar.
Thank you, Katie, for the introduction. I will start by giving a brief overview of what is river scour and why it is important. River scouring is the removal of sediment or engineered materials from the bed or banks of a watercourse. It occurs when the forces imposed by the flow on a sediment particle exceed the stabilizing forces. River scour can occur gradually or periodically during floods. This depends on the characteristics of the riverbed, the sediments, and the capacity of the river to transport sediments. River scouring may occur due to high flows or due to a change in the riverbed slope, causing extreme localized hydraulic forces. Okay, so why is assessing river scour important? Thousands of bridges throughout the UK are historic, listed and of varying building material. They present an asset of approximately £10 billion. They often carry key infrastructure such as utilities, communications, and others. River scouring is an important threat to bridges as well as to in-river structures, flood defenses, and electricity pylons. Recent years have witnessed major storm events causing significant rise in river stages and increased river flow velocities. Storm Desmond in December 2015, for example, caused huge damage to bridges across Cumbria, with a repair bill of approximately £4 million. The national park suffered 257 damaged bridges. Following Storm Frank, also in December 2015, £3 million is approved for remediation of damage in Scotland. Scour-related damage and failure results in costly repair and isolation of communities. According to predicted future weather scenarios, the extreme weather events similar to those recently observed are set to increase. The Climate Change Committee's recent independent assessment of UK climate risk has highlighted that the risk to bridges and pipelines from future erosion requires further investigation. Generally, scour is analyzed by hydrogeologists, hydrologists, and hydraulic modelers for specific case studies and at a site scale. These focus on erosion and scour to construction and protective materials. The inclusion of detailed rock and sediment properties is sometimes overlooked. In addition, there are limited fluvial scour models that provide a national overview of the scouring hazard and even fewer that include landscape evaluation from a geoevolution perspective. This gap neglects important factors that could improve understanding and modeling of scour risk in riparian environments and reduce the amount of over or underestimate of scour potential in the model outputs. This work takes the first major step in achieving this by providing a combined geological and geomorphology assessment tool using site-specific case studies to build a national scale model. So why have we developed GeoScour? Following severe storms and flooding over successive winters, the BGS recognized river scouring as an important threat to in-river structures such as bridges. We also identified a gap in current scour modeling, where the geological deposit material having little influence or consideration in current modeling algorithms. Geological data is a key input into the predictive models and is an invaluable resource for infrastructure risk and catchment health assessments at both catchment and reach scales. This data product provides an improved toolkit to more easily assess the scour risk, now and in the future, to help infrastructure providers and funders prioritize resources and to identify remedial works to prevent disruptive failures. So what are the applications? We expect that BGS GeoScour can provide Great Britain-wide assessment of geological factors that contribute to river scour, to feed into decision support tools and hydrological modeling, to provide data that can be included into other assessments for broader ecological, morphological, and societal impact analysis, to advise asset owners or managers, for example, local authorities, on actions required to minimize the threat of scour, to help with the assessment of scour hazards under projected climate conditions, which means future conditions. I will hand over to Clive and Rob now, who will tell you more details about the product. Thank you.
Thanks, Majdi. Hi, yes, I'm Clive and I'm a GIS analyst and I was technical lead on the GeoScour project. So the GeoScour dataset product is designed to be used by a wide range of stakeholders with differing needs and therefore can be interrogated at multiple scales. So of the 3 tiers of datasets available, Tiers 1 and Tiers 2 are the open datasets, which can be freely accessed via the BGS Geo Index or downloaded from the BGS GeoScour product web pages. So the Tier 1 dataset, shown here on the left of the slide, provides a summary overview which identifies and describes the relative catchment scale characteristics in terms of landscape evolution, sediment availability, and typical catchment response in flood conditions. It can be used to provide a high-level overview for incorporation into catchment management plans, national reviews, and catchment comparisons. Now, the Tier 2 datasets, an example of which is shown on the right, are available as smaller catchment areas, calculating using the Water Framework Directive river water body catchments for England and Wales, and the Scotland catchments from the Scottish Environment Protection Agency, SEPA. These were selected as they are readily available and widely used by practitioners, making the data easy to interrogate into existing systems and with other datasets. The focus of Tier 2 is on providing data for more detailed catchment management and natural flood management schemes. This can be utilised by regional stakeholders such as local authorities, national transport authorities, rivers trusts, national parks as well, when devising their catchment management strategies and assessing susceptibility of a wide range of asset networks. This latest release consists of 8 data layers at catchment level, which is at 1 to 250,000 scale and includes updates to the catchment flood accommodation, catchment morphology, and catchment geological runoff potential, with the addition of new data layers providing information on catchment surface geology susceptibility. I'll now quickly run through these data layers in a little more detail. So we're starting with the updated layers. The Tier 2 catchment flood accommodation dataset provides an estimate of the amount of space available in the catchment for flood waters to dissipate into, both as a percentage and as an area of the catchment. This is calculated according to topography and considers flooding equivalent to a 5-metre rise in water levels. It's worth noting that flood defences or artificial flood constraints are not accounted for in order to provide a baseline assessment. The catchment geological runoff potential dataset provides a summary representation of the propensity for surface water to drain into local watercourses, considering the geological properties and permeability of the underlying geology of a catchment. This information is provided as the area coverage of each runoff potential class and identifies the dominant class and the worst case for each catchment area. The morphology of the catchment relates to its geological history and provides an indication of the sediment likely to be available, which is a key control on a river's propensity to scour. The catchment morphology dataset analyzes the dominant morphology type per catchment area, taking into consideration of catchment processes. This is a domains dataset with catchments attributed into one of 4 categories: uplands, lowlands, hill and vale, or mountain. The new dataset is the catchment geology susceptibility layers. These are an open version of the Tier 3 river scour susceptibility dataset layers, and they provide a catchment level summary of the individual scour susceptibility classes assigned to each river. Within each catchment, the entire length of the river has been calculated for each scour class and are provided as lengths per class in kilometres. These summary statistics are available for worst, average and best case scenarios for catchment susceptibility to superficial deposit scour. Taking the example of the average case surface geology susceptibility for the Conway catchment in North Wales, the Tier 3 data is shown on the left and has attributed every river reach with the susceptibility class based off the geology that it intersects. The susceptibility network is summarized into a catchment polygon, which displays the dominant susceptibility class, shown here to be medium, as yellow by indicated in the yellow. This layer also provides the lengths of river which fall into the susceptibility class per catchment, as you can see on the attribute table on the right. These new and updated Tier 2 data layers have been recalculated using newly available elevation data, updates to in-house BGS datasets, and summary statistics from updated Tier 3 data layers.
Thanks, Clive. Afternoon, everyone. I'm Rob, and I'm a geospatial analyst who's worked on the development and marketing of the GeoScour data product. And I'm now going to take you through some of the new and updated features of the Tier 3 premium data layers. So the Tier 3 datasets provide detailed riverine information for assessing the propensity for river scour at any given reach of river across Great Britain. And this national coverage is demonstrated here on the left of the slide. It's intended for use as an input into hydraulic and sediment transport models, as well as integration into screening or planning tools. And these tools can provide hotspots of potential risk areas to aid in the prioritization of remedial action or to help define river adjacent infrastructure, which is most at risk. This can be achieved at a catchment scale, as shown here in the middle panel, again using the Conway catchment in North Wales for reference. The Tier 3 data can be utilised to assess the geological susceptibility of bridge infrastructure, indicated here by the blue dots, across the whole catchment, as well as honing down to reach level, as shown in the right-hand panel. As such, Tier 3 data is aimed at users such as environmental and engineering consultancies, geohazard modelers, and local authorities for conducting infrastructure risk assessments and developing predictive hazard models. This latest release consists of 9 layers at riverine level, which is 1 to 50,000 scale, and includes updates to the river geological properties, river morphology, and surface geology susceptibility layers, with the addition of new data layers providing information on the bedrock geology susceptibility and river lateral erosion. And I'll now quickly give an overview of these updated and new Tier 3 layers. So starting with the geological properties layer, this provides information on the potential and ease for riverbed and riverbank materials to be eroded and dissolved, considering density, strength, and mineralogy properties of the materials per river reach. The river morphology layer contains information on the key morphological characteristics of a catchment, namely the flood accommodation space, which Clive discussed earlier, the river fall, which is the difference in elevation between the start and end of a river reach, divided by the distance between these points, and the sinuosity, which is a measure of the deviation of a river from its shortest possible path. It's worth noting that these data do not include any artificial defences or modifications to the river, but rather it's an assessment based purely on the geology and the terrain morphology. And this is useful to understand, especially in cases where artificial features might fail or no longer be maintained. The surface geology susceptibility layer is an assessment of the uppermost deposits along a river. And these will be superficial deposits where present, or bedrock where there's no superficial deposits present. Both analyses of the surface and bedrock geology are provided as average case, best case, and worst case parameters to convey the variation and heterogeneous behaviour of geological deposits. And this also allows the user to consider both end members for scour potential according to their needs. These data layers identify primary geological properties influencing scour potential, including material density and mineralogy. Considering the new layers in greater detail, the bedrock geology susceptibility layer provides an assessment of the underlying bedrock deposits for susceptibility to scour. And these data assess the susceptibility to scour of the bedrock geology, whether there are superficial deposits present or not. This classification is important, especially in areas where bedrock has a higher susceptibility to scour, such as soluble rocks. And even where superficial deposits are present, it's important to understand the underlying properties of bedrock, as more frequent or extreme flood events may end up removing the overlying sediment to expose the bedrock to erosion. And here you can see on the right-hand side of the slide, the national distribution of bedrock susceptibility for the average case parameter. Finally, the river lateral erosion layer provides an assessment of any lateral change in susceptibility to scour, which is calculated on the scouring bank of a river course in the direction of river flow. As you can see from the schematic on the slide, the scouring bank is on the outside of a river bend, and where this changes from a hard resistant lithology, represented by the dark grey band on the diagram, to a softer lithology, represented by the yellow band, the stability of the scouring bank is reduced and susceptibility to lateral scour increases. An interpretation of the geology and its susceptibility to scour is assessed over set distances using transects perpendicular to the river line. The assessment is based on the worst case geological susceptibility data and considers transects up to 200 meters from the line of the river. This assessment allows owners of riverside assets, such as road or pipeline infrastructure, to assess the location of any change in geology and therefore change in susceptibility. And the attribution is assigned to regularly spaced points along the river line. All of these new and updated Tier 3 layers have been recalculated using the latest OS Open Rivers data and applies BGS scientific understanding regarding the influence of geological properties of bed and bank materials to their susceptibility to erosion. Now, I appreciate we've covered quite a lot of ground there and jumped between constituent data layers of all 3 tiers. So just to summarize, the BGS GeoScour data product consists of 3 tiers of data. Tier 1 is at catchment scale. Tier 2 is at sub-catchment scale. And these first 2 data packages are openly available via the BGS GeoIndex and website. And Tier 3 is a licensed data package at river reach scale. For more case study examples of potential applications of GeoScour data, please see our recently published Esri story map and blog posts, which can be found on the BGS website or social media channels. And I'll now hand over to Katie to discuss how the data can be accessed.
Thank you, Rob. So for further information about the GeoScour datasets, please visit our BGS web pages and search for GeoScour. As mentioned previously, we have created both the open and the premium commercial versions of the datasets. So the open can be viewed via the BGS GeoIndex or downloaded from our data web page. The premium datasets, which provide a richer river level output of information, are priced upon catchment areas. So to encourage and enable the use of our third-party commercial applications and products, we do offer a data exploration license, and this allows people to evaluate BGS data and use it in a development stage of any commercial innovation. So to speak to us about accessing the data and the various licensing options, please just contact our digital data email, as you can see there on this last bullet point. So I'll now ask our panel members to switch on their cameras for our Q&A session. If I stop sharing. Okay, there we go. Right.
I see we have Richard's given a question about the catchments.
Yep, go on then. Do you want to read that one, Clive?
Well, I can do, yes. It's because these are fixed from open data sets from Water Framework Directive for England and Wales, the rivers water body catchments, and the Scottish catchments from the SEPA, basically. And our understanding is that these, as they are readily available and widely used by practitioners, you know, we can make these, it's making the data easy to integrate into any existing systems or with other data sets. So they are fixed. I know there's a granularity with catchments, and we could have had it at any scale, but we decided to go by these data sets.
Okay, thanks, Clive. So there's one on, can you give examples of how the data has been used in the market? Rob, do you want to take that one?
Yeah, happy to. So GeoScour has been used in a wide range of market sectors and organisation types, really, including academic institutes, local and national governments, as well as cultural and natural conservation trusts and environmental and engineering consultancies. And I guess also geohazard modelers too. To give a couple of specific examples, the Tier 3 data has been used previously by a national transport authority to assess their road infrastructure network for susceptibility to river erosion. And another example comes from the geohazard modelling sector, where GeoScour data was incorporated into a hydraulic model to predict erodibility by combining geological and hydraulic parameters.
Thanks, Rob. So another one, so this one's about climate change. Maybe Majdi, you can take this one. The current data is about the conditions today. What plans does BGS have for adding climate change aspect to the data set?
Yes, thanks, Katie. I think Tier 1 and Tier 3 of the products, they include the amount of water that drain into the water courses. Now, the potential of the variability of this can be assessed under future climates. So, and then I think, so our plan, BGS plan, is to re-evaluate scour potential due to changes in catchment wetness and add the climate change aspect to the GeoScour product. So yeah, we are planning to add that, you know, to the climate change factor in the GeoScour product, hopefully soon.
Great, thank you, Majdi. So there's one around different uses of the data. Clive, maybe you can take this one. When would you recommend I use the best, average, or worst case values?
Okay, yeah. Yeah, that's true. Good. Well, GeoScour allows the user to consider the extremes for scale potential. So based on their needs, according to their needs, if you like. So the worst case rating in GeoScour will convey the weakest, most susceptible mineralogy properties of the whole deposit, whilst the best case rating will convey the strongest, least susceptible properties. So if you have a high value or critical assets in close proximity to the river, with no defences and the river has high flow rates, then it may be worth considering the worst case rating for that asset. However, if you have lower value, more modern, resilient assets behind flood defences or in areas of low flow rates, then the best case scenario might be more appropriate. So as a first phase assessment, we can recommend reviewing the average and the worst case scenario ratings. Then based on your understandings about your assets, the value of the resilience of your asset, choose a scenario that's most appropriate and go from there.
Thanks, Clive. And I think that answers another very similar question that was asking about how you handle local facies variation in the properties. So I hope that's answered that one. There's another question around where we get the information from on scour susceptibility to density and mineralogy and the SPTN values. Do you want me to take that one? So that's coming from our in-house geotechnical database and geological data in-house. So we have a lot of engineering geotechnical information that feeds into some of our internal data sets.
There was a second part to Richard's initial question asking about, is there any differential between surface sediments and subsurface geology? Just to finish that one off, yes, there's two data layers that consider this. We have our surface geology susceptibility, which considers the surface deposits, which will be superficial where present, or bedrock where they're not present. And then we have a tier 3 layer, which considers just the bedrock geology susceptibility to scouring. So the surface susceptibility is available at tiers 2 and 3, and bedrock susceptibility is available at tier 3.
Thanks, Rob. Okay, another question. When is it appropriate to use the open data rather than the premium data? Who wants to take that one?
I can take that one if you like. So the open data sets are suitable for use in regional or catchment level assessments of catchment characteristics. So this can include things like national reviews or catchment comparisons for local authorities and national environmental protection agencies, or even asset owners with wide-ranging infrastructure networks such as transport authorities. And these open data layers will also be a useful reference layers when planning and implementing catchment management strategies, with the premium tier 3 license data applicable for higher resolution site-specific assessments and inputs into hydraulic and sediment transport models.
Thanks, Rob. I'm just aware of the time. Let's do a final one, I think. Do you incorporate current and historical weather in your models?
Do you want me to take that?
Thanks, Majdi. Yeah.
Yeah, so currently the product accounts for the volume of water that the catchment can contain. So we don't process exactly the historical rainfall data through the model as yet, but it's so the volume, the wetness of the catchment is calculated based on a 5-meter depth of water. In that respect. So there is no time series calculation to assess the risk or the susceptibility at this stage in the product.
Yeah, and I think the tier 3 data is designed to be incorporated into different hydrological models as well, which would have that sort of data. So where our data is coming purely from that geological perspective. And just one final one about clarifying the license and pricing options of the various data sets. So as we've mentioned, there's the premium license data is available as a complete package of data sets, and that is based on a catchment basis. And there are different tiered prices based on the catchment size for those. Alternatively, there is also a 10-kilometre length of data that's available if you're looking at smaller areas, say around bridge structures. So the best thing to do is just to contact us at the digital data email address. Okay, so we are past 1:30, so I think we're finished there. We'll try to get back to people if we haven't covered anything, but please do feel free to get in touch with us at our digitaldata@bgs.ac.uk email. And thank you everyone for attending. We hope you found this webinar of interest, and we will make this recording available on our website soon. So again, if there's anything further, please do not hesitate to get in touch with us. So for now, it's goodbye from us, and I hope you have a good afternoon.